Today, I'm going to cover Hungarian method in this session. So, what are the steps involved in the Hungarian method? How to solve the problem by using Hungarian method? We are going to discuss in this session. After completing this session, we can able to apply optimization techniques for finding initial basic feasible solution and move towards optimality in transportation problem, which also includes both unbalanced and maximization cases. And the first step in the Hungarian method is, first we need to deduct the smallest element in each row from the other elements of the row. So deduct the smallest element in each row from the other elements of the row. Smallest element we need to take out and we have to deduct that element from the other elements of that particular row. And the matrix thus got is known as row opportunity cost matrix, that is called ROCM, row opportunity cost matrix. And the logic here is, if we assign the job to any machine having higher cost or time, then we have to bear the penalty. So what is the logic we are going to use is, whenever we have assigned the job to a machine which is having higher cost or time, then we need to bear the penalty. So if we subtract smallest element in the row, if we subtract a smallest element in the row or from all other elements of the row, there will be at least one cell having 0. There will be one cell which is having 0, that is 0 opportunity cost or 0 penalty. In order to make 0 opportunity cost or 0 penalty, we have to subtract smallest element in the row from all the elements of the row. There will be at least one cell which is having 0. Hence, that cell is more competent for assignment. Whatever the cell which is having 0 opportunity cost, that cell is more competent for assigning the value or allocation of that particular row. And step 2, deduct the smallest element in each column for other elements of the column. The same way how we have done in the row wise, in the same way we have to do column wise also. Smallest element we need to find in each column, and from the other elements of the column we have to subtract. And the matrix thus got is known as column opportunity cost matrix, that can be taken as COCM. Row opportunity cost matrix, that is ROCM. Column opportunity cost matrix, COCM. Here also, by creating a 0 by subtracting smallest element from all other elements, we can see the penalty that one has to bear, where 0 opportunity cost is more competent for assignment. How we have got 0 element in the table in the row wise, in the same way here also we may get the 0 element, at least one element as the 0. So 0 opportunity cell is the more competent for assignment. Whatever the 0 element is there, that is nothing but opportunity cost is 0. So that is more competent for assignment or allocation. And here we are going to add COCM and ROCM to get the total opportunity cost. We have to add COCM, column opportunity cost matrix, row opportunity cost matrix. We need to add in order to get the total opportunity cost, that is TOCM, total opportunity cost matrix. And after getting the total opportunity cost matrix, that can be got by simplifying, doing row operation on column opportunity matrix or column operation on row opportunity cost matrix. So this method is simple one and saves time. So with this, we can go with the one row operation and one column operation. We can save the time, and it is very simple one. Doing row operation on column opportunity matrix means deduct the smallest element in the row from all other elements in that row in column opportunity matrix and vice versa. So here, whenever we are going to uh, do the operation, row operation on column opportunity matrix is nothing but we are going to deduct the smallest element in the row from all other elements in that particular row in column opportunity matrix, and also vice versa. If you take the column operations on row opportunity matrix, means we have to deduct smallest element from the column from all other elements in that particular column. The property of total opportunity cost matrix is that it will have at least one zero in every row and column. So the property of total opportunity cost matrix is that it will have at least one zero in every row and column. All the cells which have zero opportunity cost are eligible for assignment. Whatever the cells which we are going to have zero as the opportunity cost are eligible for assignment. And the next step is, once we get the total opportunity cost matrix, which is going to cover all the zeros. Once if we get the total opportunity cost matrix, which is going to cover all the zeros by minimum number of horizontal and vertical lines. So once if we get the TOCM, total opportunity cost matrix, which is going to cover all the zeros by minimum number of horizontal and vertical lines. First cover row or column which is having maximum number of zeros, and then next row or column having next highest number of zeros, and so on until all zeros are covered. Remember, only horizontal and vertical lines are to be drawn. So we need to write only horizontal and vertical lines. And the next step is, if the lines thus drawn are equal to the number of rows or columns, we can make assignment. So once if it is a square matrix, we can make the assignment. If lines are not if lines drawn are not equal to the number of rows or columns, then we have to go to step 7. To make the assignment, search for a single zero, either row wise or column wise. If you start row wise, proceed row by row in search of single zero. Once you find a single zero, assign that cell by enclosing the element of the cell by a square. So we have to enclose the element of that cell by a square. Once all the rows are over, then start column wise, and once you find single zero, assign that cell and endorse the element of that one cell to square. And once assignment is made, then all zeros in the row and column corresponding to the assigned cell should be cancelled. Once the assignment is made, we have to, then all the zeros in the row and column corresponding to the assigned cell should be cancelled. And continue this procedure until all assignments are made. Sometimes we may not find single zero and find more than one zero in a row or column. So whenever we are having two zeros in a row and column, then it indicates that the problem has an alternate solution. We can choose any of that. We can write alternate solution. This situation is known as tie in the assignment problem. And step 8, if the lines drawn are less than the number of rows or columns, then we cannot make the assignment. If the lines which are drawn are less than the number of rows and columns, then we cannot make the assignment. So hence the following procedure is to be followed whenever it is not a square matrix. Then what is the procedure we need to do is the cells covered by the lines are known as covered cells. The cells which are covered by the lines are known as covered cells. The cells which are not covered by the lines are known as uncovered cells. The cells at the intersection of horizontal line and vertical lines are known as crossed cells. And we are going to, the first one, identify the smallest element in the uncovered cells. First we need to identify the smallest element in the uncovered cells and subtract this element from the elements of all other uncovered cells. And next we need to subtract this smallest element from the elements of all other uncovered cells. So whatever the uncovered cells are there, from those uncovered cells we have to subtract this element and add this element to the elements of the crossed cells. Add these elements to the elements of the crossed cells and do not alter the elements of covered cells. And once again, cover all the zeros by minimum number of horizontal and vertical lines. We need to cover all the zeros by minimum number of horizontal and vertical lines. Once the lines drawn are equal to the number of rows or columns, assignment can be made as said in step 6. So once the lines are drawn which are equal to the number of rows or columns, assignment can be made as said in the step 6. If the lines are not equal to the number of rows or columns, repeats the steps 7a and 7b until we get the number of horizontal and vertical lines drawn which are equal to the number of rows or columns and make allocations as explained in the step 6. And note, for maximization, same procedure is adopted once we convert maximization problem into minimization problem by multiplying matrix by -1 or by subtracting all the elements of the matrix from the highest element in the matrix. Once we do this, the entries in the matrix gives us relative costs, hence the problem becomes the minimization problem. Once we get the optimal assignment, the total value of the original payoff measure can be found by adding the individual original entries for those cells to which assignment have been made. And these are the references I have considered: operations research and introduction, Hamdi A. Taha, Pearson Education, and introduction to operations research, Frederick S. Hillier, Gerald J. Lieberman, McGraw-Hill Education, and operations research, S.D. Sharma, Kedarnath, Ramnath, and Co. And these are the web references I have considered: Khan Academy, Geeks for Geeks, and Tutorials Point. In this session, I have covered what are the steps involved in the Hungarian method. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.